What's up, ladies and gents? Welcome back to Mr. Joe's Math Show. Today we're talking about geometric sequences and 5.6. We before have talked about arithmetic sequences in Chapter 3, which have to do with linear functions. Now we're going to look at geometric sequences, which deal with exponential functions. Okay, so looking at this problem right here with this nice snow coat, just in time for the winter, it says imagine working part-time at a clothing store. Each week a coat doesn't sell, it's marked down. Its price is marked down 20%. What will the sell price for the coat shown at the right be after 3 weeks? Okay, so we can say the first week it's going to be $80 because they just got it. Brand new $80. The second week it's going to go down 20%. So we can figure out what 20% of 80 is by doing 80 times 0.20. Since you move your decimal back twice when it's a percentage. And 80 times 0.20 is going to give us 16. So it's not going to be $16, it's going to be $16 off. So 80 minus 16, that coat price would be what, $64 in the second week? Okay, another way you could do that is you can say this is going to be 80 times, originally you were paying 100% for the coat. You're going to mark it down 20%, so subtract 20%. That's going to be 80 times 80%, which is just 80 times 0.8. Okay, and that also gives us 64. Okay, so you're just, either way works. You can figure out how much dollars off it is and then subtract it first, or you can do how much percent it is off and then multiply those. And then the third week, we're going to take our previous price, $64, and I like to do the percentage way, so I'm just going to multiply it by 0.80 since it's 20% off. And that gives us 64 times 0.8 is $51.20, 51.2. So in the third week it's going to be $51.20. Okay, and we could obviously keep going for the fourth week and the fifth week and so on. Okay. So, in the solve it, these sales prices form a geometric sequence. In a geometric sequence, the ratio, that means you're multiplying or dividing, of any term to its preceding term is a constant value. So these have a constant ratio, whereas arithmetic had a common difference. Okay. A geometric series with a starting value a and a common ratio r is a sequence of the form a times ar, a times r squared, a times r to the third, a times r to the fourth, and so on. So the recursive part, so the recursive again has two parts to it. The first, you have to say what your first term is, your initial term, and then you say what the pattern is by multiplying by r. So in this case you're just filling in two things, the first term a, and then your common ratio r. Okay, and then the explicit is going to be here, and this one you just have one part to it, and you're filling in your first term, a1, your common ratio r. So it's a1 times r to the n minus 1. Okay, so that's the recursive and the explicit formulas for geometric. So it's a little bit different than for arithmetic, but similar in the way that you're only filling in the first term and the common ratio in this case. So still only need to know those two things. Okay. Every sequence, geometric sequence, has a starting value and a common ratio. The starting value and common ratio define a unique sequence. Okay, so looking at these, it says which are geometric sequences. So if you want to find your common ratio, I'm just going to look at 200 divided by 20. Well, that tells me that I'm multiplying this by 10. 2,000 divided by 200 is also 10. 20,000 divided by 2,000 is also 10. And then this one is also 10. So it's multiplying the same amount each time. So that is geometric, and your common ratio would be 10 because you're multiplying by 10 every time. Now this one, 4 divided by 2 is 2, so you're multiplying by 2 there. But then 6 divided by 4 is 1.5. So this one is not geometric. This one's actually arithmetic because it's adding 2 every time. So not geometric there. This one, it goes from -5 to +5 and so on. So we take -5 divided by the previous term, which is +5, we get -1. 5 divided by the previous term, -1 again. And these are all multiplication. -1 again, and -1 again. Whoa, I just did lots of weird things there. Times -1. Alright, So this one, even though it looks kind of funky and doesn't really look like a geometric sequence, it actually is because it's multiplying by -1 every time. Okay, so you're multiplying by the common ratio, and your ratio would be -1 in that case. This one would have a common difference because it's arithmetic of +2, +2. Okay, next. Hello. Okay, go ahead and try these ones, and then I will do them as well. Okay, pause this in 3, 2, 1, pause. Alright, so the first one is geometric because you're multiplying by 2 every time. 3, 6, 12, 24, so on. B is actually arithmetic because it's adding 3 every time. G, we have fractions, so those are kind of scary, but it is geometric because you're multiplying by 1/3 every time. The top stays 1, the bottom is increasing by a factor of 3, you're multiplying by 3. So that tells us we're multiplying by 1/3. And then D, it has a pattern, you're adding 1 more each time, but that's neither arithmetic nor geometric, so we just say neither on that one. Even though it is a sequence and it has a pattern, it's neither of the two that we've discussed. So, alright. So let's look at the recursive and explicit formulas here. So the first thing we need to know is what A1 is. So A1, you can also write it as we did before, like this. Either way. Our first term here is 7. Or you can do this one 7. And the next thing you need to do is find the common ratio. So I do 21 divided by 7, and that's going to be 3. 63 divided by 21 is also 3. And this one is also 3. So our common ratio is 3. Okay, so for the recursive, we say what A1 is first. This is one with 2 parts. So A1 is 7, and then AN equals your previous term, AN minus 1 times the common ratio of 3. Okay, so this goes in here, this guy goes here. For explicit, this one is the one that is more useful because we can figure out any term that we want just using one thing. So this one we say AN equals our first term, which is 7 times your ratio of 3 to the n minus 1 power. Okay, so again, your first term goes here, your ratio goes here, and the n minus 1 always stays the same. So this stays, everything else stays. So you're only filling in 2 things, your first term and your common ratio. So that is what the explicit and recursive formulas should look like. Okie dokie. Okay, so why don't you guys try this one? Okay, pause this in 3, 2, 1, pause. Alrighty, so our first term is 2. So we plug 2 in here, and 2 right here. Your common ratio is R, which is 2 as well. So we have 2 there. So 2 and 2. That's for A. It's multiplying by 2 every time. B is actually decreasing, and it's dividing by 2. So dividing by 2 is the same as multiplying by a half. So our first term is 40. So let's go there for recursive and explicit. And our common ratio is not 2 because we're actually dividing by 2, and we're multiplying by 1/2. So it's ever dividing by something every time, that tells you that it should be a fraction as your common ratio. Okay. Next one says, 2 managers at a clothing store created sequences to show the original price and the markdown price of an item. Write a recursive formula and explicit for each sequence. What will the price be after the 6th markdown? Okay, so this is okay, so this is our first term, second, third, fourth, and so on. First, second, third, fourth. Okay, so we need to find the the common ratio or common difference first. So if we look at this one, to find your common ratio, you're going to take this and divide it by the previous term, which is 60. So 51 divided by 60 gives us 0.85 for that. So we need to make sure that's the same for all of these, actually. Okay, so then I'm going to take the next one. I'm going to go 4335 divided by my previous term of 51. 43.35 divided by 51, which is also 0.85, so that checks out. And then lastly, we're going to do 3685 divided by 4335. So 36.85 divided by 43.35. And that is also 80.85. So this one does have a common ratio. So we can write the recursive formula by saying our first term is 60, and the pattern, we're going to need to multiply the previous term and minus 1 times 0.85. That's our common ratio. So basically that's saying they're marking it down 15% each week, because they're only paying 85% instead of 100%. Okay, so for explicit, we're going to say an equals our first term of 60 times by our ratio 0.85 to the n minus 1. Okay, and now let's look at the second one. So the second one is actually, you can see that it's actually just subtracting by 8 each time. So this one is not geometric, it's actually arithmetic. So let's review the formulas for arithmetic. So arithmetic, we say our first term, for recursive again, first term is $60, and then this one is adding and subtracting, so we're going to do an equals an minus 1 subtract 8, not times negative 8 because you're subtracting 8. And then the explicit is going to be an equals your first term, which is 60, plus n minus 1 times your difference, which is negative 8. Okay, so this one, your difference goes here and here. Our first term goes here and here. Okay, first term on this one, 60 and 60. And then our ratio, 85 and 85, go there. Okay, then it wants the price after the 6th markdown. So to figure that out, we just plug 6 in for n here. So 6 there, and 6 in for n there. And let's see what we get. Okay, so I calculated both of these. The first one comes out to be $26.62 for this after the 6th markdown. The second one comes out to be $20 after the 2nd markdown. So if you're wanting a cheaper price in the 6th week, shop at store number 2 or 2nd manager, whatever. Okay, moving on. Okay, so let's go ahead and try this one. Try A and B, and I will do it as well. And then pause this in 3, 2, 1, pause. Alright, so on the first one, our common ratio, I figured out, is 84 divided by 14, which is 6. So we plug that in here for the recursive and here for the explicit. First term is 14, so that goes here and here. And then for B, first term is 648, so that goes here and here. Ratio is actually 1/2, 324 divided by 648. And that goes here and here. Okay, and then you can just plug in 8 to figure out what the 8th term of the sequence should be. So let's do that really fast. Alright, so I plugged in 8 and I plugged it into the explicit formula since that's the one that's useful. And I got 3,919,104. So that's pretty big. Increases very fast. If I plug in 8 for the second one on part B, plug it into here again, plugging it into n. In the explicit, we get 5.0625. So we started at 648, and by the 8th term, it's all the way down to 5.0625. So it's decreasing very quickly. So yeah, when it's exponential, it increases quickly or decreases quickly, depending on if it is a fraction or a whole number. All right, last thing here. It says you can plot the sequence using the points n, comma, an. N is going to be the term, and then an is the term value, so like what is the first term, or second term, or third term. So if we look at this one, it says a geometric sequence has an initial value of 6 and a common ratio of 2. Write a function to represent the sequence, then graph the function. Okay, so basically when it tells you to write the function, we want to plot it out first, so we can write n, and then what an here. So we want it the first, second, third, fourth, fifth term, etc. It says our initial value is 6, so that's going to go in for A1. And then your ratio is 2, so you're just going to double it every time. So 12, 24, 48, 96. And then we want to write the function. So how can we do this? Alright, so upon further pondering, there are a couple different ways we could do this. So you can actually just write the explicit formula of this sequence, which would be an equals your first term of 6 times your ratio of 2 to the n minus 1. Or you could find the y-intercept, if you think of this as your x and this is your y. You could find the y-intercept by going to 0 on the x, and if you want to go to 0, you have to go backwards. So we'd have to, instead of multiplying by 2, you'd have to divide by 2 and get 3 here. So then, if you remember, exponential functions are written as y equals a times b to the x. A is your initial value, or your first term, or your y-intercept, which is 3. So we get y equals 3 times b, which would be actually your ratio of 2 to the x. So either of these would be acceptable answers. And to graph that, this one I think is much easier to graph. So you would do your little xy axis here, plot the y-intercept of 3, 1, 2, 3. Every time you go over, it doubles. So it'd be up to 6 here, and then up to 12. If you go this way, it'd be like 1.5. Something like this, it would look like. Okay, so that's what the graph would look like. Okay, this one is very similar. Your initial value is 2, and your common ratio is 3. So go ahead and try this one, write the function, and then graph it. Okay, you can pause this in 3, 2, 1, pause. Alright, so again, I made the table. I did first 1, 2s, and 3s here, because it tells us our initial value is 2, and then we multiply by 3 each time. So to find our y-intercept, the 0, I went backwards and divided by 3 and got 2/3. So that I put in for a. My ratio is 3, so 2/3 times 3 to the x. If you want to write it as the explicit formula, you can do that too, but either way works. So then I graphed, started at 2/3 right there, and then I multiplied by 3 as I went over. So it looks something like that. Alright, and that is all of chapter 5.6. So make sure you do the Canvas quiz, and thanks for watching. And now we'll have a guest outro by one of our own, Adam Lynn.
Alright guys, thanks for watching. This has been Brogan Johnson. Thanks for watching, Bro Gang. Like and subscribe, and we'll see you next time. This has been the greatest accomplishment of my young little child life. You should stop the video now.
Okay, thanks, bye.